So final exam. Oh, no, I'm going to do nothing because my, oh wait, I got to, okay, I think I'll do something now. All right, I'm writing now. All right, good. Okay, so there we go. So final exam. Oh, well, you're saying nothing, huh? Let me plug you back in. There we go. Final exam is, for us, is Wednesday, next Wednesday, you know, next Wednesday, 10, class time, normal class time, 10, and we stay all the way to 12. It's 2 hours. 10 to 12, we take the final exam next Wednesday. So, and I have office hours this week as normal. Office hours this week are normal, you know, which means Tuesday, Wednesday, Thursday. What am I? 9 to 9:50, the hour before your class. So I'm there this week. Office hours next week, finals week, you know. Well, I'll say next week, finals week, are always different. What are they? They are Monday 9 to 11, Tuesday 10 to 11, and Wednesday, the day of your final, the hour before your final, 9 to 10, or 9:50. So yeah, so I'll be over there the hour before your final on Wednesday, and then I'm there Monday and Tuesday. I'm also there Thursday, but you don't really care. Your final's over at that point. There we go. So there's the information for finals week. Next week is our final. What's on the final? Everything in the world. I don't remember. Ooh, I think I have it here. I'm about to drop it off with a photocopier. Yeah, I got all my finals here. So we have a part 1, part 2. Look at that, a sine-cosine graph, just like I promised. Right there, I'm looking at it. On the final. Boy, I always think I'm such an easy teacher. I'm saying exactly what's on the final. All right, so I'm looking at part 1. Part 2 has 16 questions. Part 2 is 16 questions. Part 1, I just looked at it and I put it away. Again, because I saw that graph. 16, and the other one is 10. So 26. 26 questions. There it is. 20. So it's a little bit longer than a normal test because we have a little bit longer. Not a lot longer. I guess we're normally taking 2 hours, aren't we? Well, so you're it's a little bit long. Well, I guess normally there's 20 or 25, huh? So 26 questions. There's 10 on part 1, and part 1 is, again, no calculator at all. And then there's 16 on part 2 when you can use your graphing calculator. So we're doing the same thing we did on exam 4, meaning part 1 is no calculator at all. Part 2 is you can use your graphing calculator. So, and part 1 has a lot of the trig, all the trig stuff. Anyway, you get, for notes, you get 1 full sheet of notes. Both sides. Meaning not just, oh, it's off the screen. Anyway, not just a 3x5 card. So full sheet of paper, 8.5 by 11, normal size paper. Write anything you want, front and back, and you can have it with you during the final exam. And what I'm gonna do, the way I would study is I just go over the old exams. I'm gonna put the answer keys up by the end of this week, for sure by Friday. I'll put the answer keys up. So the keys for all 4 is the keys for exams 1 to 4 on Math Excel. I'll put them on Math Excel just like the practice exams. I'll put them under the, the announcements, by Friday. So that's what I would do to study. I would just look back over your old exams, and just redo the problems. And I'll put the answer keys up there by Friday so you can do that this weekend. Rania.
The scores from our last test?
Yeah, I'll get those back by Thursday. Maybe sooner, but by Thursday. I'll get those back to you. Yeah, so you have all your exams back. Yeah, I want you to definitely have that in your hand and also know where you are point-wise. before you take the final. Remember, the final will both be the final, and if it helps you, replace your lowest among your other 4. So it'll probably count double for you. In other words, unless it's your worst score, then it would just be it. Does that make sense? It'll count double for you if that helps you, right? So for most people, one of their 4 is lower than the final. So if it helps you, the final will count double. It'll for sure count, and it'll also count as a replacement if that helps you. That makes sense? So it's a lot of points. Those 26 questions are like a double test in value. So there's hope there. You can improve your grade by the final. You could hurt your grade by the final. You don't want to do that. So, and you do need to study. You know, it kind of goes without saying, but I found it needs to be said. It would just be crazy. I always have a couple people having decent grades, and I don't know what happens. They just don't study for the final, and then it tanks them good because it is big points. And it's hard to remember. Oh, we're doing the survey thing. Is that what you're here for?
Yeah, we're supposed to take a test.
Oh, I'm getting totally confused. All right. Yes. All right. Shoot. Do I have those with me? I think I forgot all about that. Uh-oh. Why didn't I remember that? Should I talk about a pre-calculus test? Here for my online class. Yeah. Oh boy. I am sorry. I know I set that up with you and I forgot to make myself a note, huh? All right, so none of these are blank. Right. Okay. Yeah, I apologize. I don't have a blank one with me. I put them all in the assessment center. So we set up to take it here. Oh, because you couldn't do it at 2 o'clock.
Yeah, I worked 2 to 10.
That's right. I forgot about that. Yeah, I apologize. I'm sorry.
Do you just want me to email you?
Yeah, I guess so. All right. So, all right. So, any other questions on the final? That makes sense? You all good? Study hard. Go over the old exams. It's really even-handed. It's all the old exams put together. That's what it is. Same problems, really, literally. I mean, not exact numbers, but virtually. It's like taking the old exam questions and changing the numbers, basically. Yeah. Like half of each of them, or a third maybe. A third of each of the old exams with the numbers changed, basically. Yeah, that's totally it. Yeah, it'll be the same old stuff. Exactly. They'll look the same format, same. Going to, whoops, what am I? There we go. All right, so here we are. So let's do this. We're doing inverse trig functions. This is section 7.1. Remember these? We're finishing our review of trig. You had this, right? How do you do inverse? What's an inverse function mean? It means inputs and outputs are switched, right? Remember I always make the analogy of an inverse toaster. Just to give you something real to think about. What would an inverse toaster do? A normal toaster, you put in bread, right? Normal toaster, put in bread, get out toast. I mean, that's my function there, my toaster function, right? Normal toaster, put in bread, get out toast. So an inverse toaster, I'm not just being silly, I have a point here. You'd put in toast, right, and you'd get out bread. Right, switch inputs. So, same way. Normal trig function, what do you put in? Normal trig function, you put in an angle, you get out an answer. Like cosine, sine, tangent, whatever. That's how a normal trig function works. Normal cosine, not cosine inverse, right? Normal cosine. So then inverse cosine, what are you going to put in? An angle? You're going to put in an answer, and you're going to get out an angle, right? So that's the fundamental thing to keep in mind as you're doing inverse trig. You plug in an answer, get out an angle, right? It reverses things, right? That's what inverse functions do. They swap inputs and outputs, all inverse functions. So, okay, so then I look at this. Bless you. Okay, so you put in this is the answer, therefore. That negative root 3 over 2, That's the answer. And they're asking, hey, what's the angle? What's the angle that would produce that answer? That's what they're doing with an inverse cosine question, aren't they? That's what inverse functions do. They switch they plug in the answer and ask you for the plug-in, basically. So how do we do that? Okay, all right, we got it. So how do you find out what angle would produce that answer? Well, you know what I'm going to say, unit circle, right? No calculator on the final for this stuff as well. So this is valuable. I'm trying to get you ready for calculus, where you'll need to do lots and lots of trigonometry. Well, calc 2 especially. All right, so what angle produces, is this the small, medium, or large? The root 3 over 2. That's the large. And it's negative large. Now cosine. Is cosine the x value or the y value? X. So they're saying, where is it negative large x value? That's what they're saying. Where, remember the dots. It's like we have 3 dots here, 3 dots here, 3 dots here, and 3 dots here. Right? Let's think this backwards. What angle, what spot, what dot, if I would say, hey, consider those 12 dots. 3 dots, 3 dots, 3 dots, 3 dots, 12 dots. Among those 12 dots, which dot is back a lot? Back the largest amount. It has the most negative x value. There's 2 dots. Do you see them? This one and this one. They're both back a large amount, aren't they? It's those 2. Right? See how I thought that out? It's those 2 locations by using the unit circle. Back, those dots are both back the most, aren't they? Back the largest amount. Now, why is there 2 of them? Which one do we want?
The one above.
Why? Because what?
Because that cosine is negative. Well, they're both negative, actually.
Yeah, they're both negative. Which angle is this? What's this one right here? This one right here.
Pi over 2.
Well, let's just give degrees. I think better degrees. Don't give me no pi stuff. It's 150, right? Are we good? Because it's just 30 above 180, right? It's just 30 before 180, right? And what's this one down here? 210 is 30 more, right? So the 2 angles we're talking about are 150 and 210, right? Now, if you hit the buttons on your calculator, of course you don't get that on the test, it'll tell you 150, or whatever pi thing that is. Why? Why is it only giving us the 150 and not the 210?
Because of the restriction of cosine inverse.
What's the restriction?
Negative. It's from 180 degrees to 0 degrees.
Good job, Robert. I am impressed. Nobody ever knows that answer. Really. I mean, nobody ever. Yeah. Remember trig? There's restrictions on the inverse functions. In other words, there would have been 2 answers, but they restrict it, and cosine inverse only goes from 0 to 180. They say we only want the answers in this top half. Don't give me any answers not in that top half for cosine inverse. So therefore the answer is only the 150. Do they want, they want the pi thing. No, they want me to do that in terms of pi. How do you take one, on the test I'm fine. 150 is fine with me. How do you turn that into a pi kind of thing? I'll come down here and switch. You remember how to convert that? You take the 150 degrees times, and you just convert. Now, if you want to convert, you got to put degrees on the bottom and radians on the top. Why? Because you want degrees to cancel. You want to get rid of degrees. Remember when you convert units? You're taking any chemistry or those kind of things. When you convert units, it's just like dealing with a fraction. I'm going to put some amount of degrees. What is it? 180 degrees is pi radians. How did I know to put the 180 on the bottom? Because I want degrees to go away, because I'm getting out of degrees going into radians. So whatever you want to get rid of, you put in the bottom. So it'll cancel. I want to get rid of degrees. I want to come out of degrees into radians. So you put them in the bottom, right? So and then reduce that fraction. 15 18, so I cut divided by 10, top and bottom, got rid of the zeros. And then divided by what? 3? Top and bottom would be 5 6 pi. And some of you probably already knew that was 5 6 pi. If you just can think in terms of radians well, then you know that's 5 6 pi. There it is. Is that good? You okay on that? Questions on that one? Please take a little bit of thinking. Is that okay? All right. I know it's tricky. Let's try that one. Sine inverse of 1. So, again, draw the unit circle. So we're saying sine inverse of 1 equals, so remember, the 1's the answer, and we're looking for the angle. It's an inverse function. It's switched. The answer is now in the parentheses, right? We're looking for the angle. That's what an inverse function of any kind does. It switches inputs and outputs. The answer goes in the parentheses now. So find the angle whose sine has an answer of 1. Well, draw your unit circle. Think about there's 3 dots in every quadrant. And there's the axis points. I didn't put those on last time. There's the four corners, right? The 4 axis points, plus 3 dots in every quadrant that are our memorized values. Which of those has a sine answer that's 1? So go say it out loud. Give everybody a chance to think about it. Look at that picture. Think about that. Ask yourself, sine. Is sine x value or y value? So you got to be clear on it. Is sine x or y? Sine is y, right? Cosine is x, sine is y. Y is heights. We're talking about a height, right? Sine is y value. So we're saying, where is the y? Where is y equal to 1? The answer to the y is 1. That's what it means. To say sine is 1, the answer to sine is 1, you're saying the y value is 1. So where is the y value? Which of these, look at those, whatever it is, 12, 15, 12, 16 dots up there, and say which of those 16 dots has a y value, a height of positive 1? Just this one right here. He has a height, right? He's over 0 up when he has a y value of 1, doesn't he? He's the only one. That makes sense? So that's the spot. Let's see, he's 90 degrees. Or, how's that in terms of you take 90 degrees times pi radians over 180 degrees. That's 90 over 180 pi. Reduce that, pi over 2. 90 degrees. Is that good? Tim?
So if the answer was something other than 1, like the square root of 3 over 2,
Something like
would
that.
sine have a different restriction than cosine?
Yep, sine has a different restriction. Yep. Let me wait till we need it. I'll give it to you. Yep. And normally, you always get 2 possible answers, unless it's one of these axis points like this one was. And then you got to decide which one based on the restrictions, like we did last time for cosine. So I'll give you all the restrictions, I'll give you the rules in a minute. Let's wait. Okay, try that one. So again, this is the answer. We're looking for the angle, right? Inverse is an inverting of input and answers. Okay, so looking at the unit circle, thinking about the, I'm not doing my dots very well. Thinking about the 3 dots in each quadrant and the 4 corners, the 4 axis points. Which of those, now cosine, is cosine x or y? Cosine is x, right? Sine is y, cosine is x. So x, so this means they want an x value of negative 1. Which of all those 16 dots has an x coordinate, an x value of negative 1? Him right here. He's back 1, up 0. He's the only one that has an x value of negative 1, huh? So that's 180 degrees, better known as pi. Good, so there's not 2 dots for the coordinate, the 4 corners. So it's just 1 inch, negative 1. Or I mean 1/8 pi. Good? Is that okay? Be on part 1, in other words. Part 1's no calculator. So yeah, so they're just saying, hey, tan inverse of 13. Just hit the buttons on your calculator. Got to be in. Make sure you're in radian mode though. You guys know how to change the modes? Hit the mode button, you know, on the TIs or whatever calculator you're using. Make sure you're in the right mode. Hit the tan inverse of 13. Anybody got an answer in radians? One more time? 1.494. They say 3, hundredths place, so we'll just say 1.49, I guess. Just want 2 places. Anybody else getting that? It sounds like a couple people got that, huh? Okay, good. Does that make sense? You guys able to get that? Make sure you're in the right mode. If you have any trouble with that, grab me after class. So let's just hit the buttons on the calculator. That'd be on part 2. Probably that's not on the final at all. But anyway, a little tricky. Okay, let's talk now about the restrictions. Inverse functions need to have restrictions on them. I'll give it quick. There's a deep story behind it, and I don't have a lot of time for a deep story. Do you remember what's a one-to-one function? Well, let me start there. What if I have a graph like this? Some kind of weird, I don't know, graph like that. Is that a function? Is that graph a function graph? Well, remember the vertical line test? It fails, so it's not, right? So I'm just reminding you that if a vertical line hits 2 points or more, more than 1 point, then the thing's not a function, right? Fails the vertical line test, not a function, right? That's true. So now, what if you have something like this? That's a function, right? Because any vertical line only hits 1 point. So that's a function. But it fails the horizontal line test, which means it's not a one-to-one function. Remember, it's been a long time since we talked about that. We really like one-to-one functions. That one's not one-to-one. Even though it is a function, it's not one-to-one because there's not one x value for every one y value. Right? Like that looks like y equals x squared, doesn't it? For example, x is positive 1 or negative 1. Both go with y positive 1, don't they? Am I going too quick? You with me on that? Right? Plus 1 or minus 1 squared. Plus or minus 1 squared is plus 1 in that equation. So you see y equals x squared is not a one-to-one function. There's not one x value for every one y value. Right? It's fine. He's still a function. He passes the vertical line test. But he's not a one-to-one function, which means what? He's not invertible. If you invert him, right? Because right now, as he stands, he is a function, but there's not one x for every one y. These two x's both go to that one y, right? X plus 1 and minus 1 both go to y positive 1, and on you go. It's not just that. You could say x plus or minus 2 both go with y 4, don't they? Right? So notice there's 2 x's for every one y. Well, who cares? Why is that the end of the world? Well, it's not the end of the world, but it means he doesn't have an inverse. Because if he fails the horizontal line test, then when you invert him, he'll fail the vertical line test, and thus his inverse function won't really be a function. Make sense? So that's why we really like functions that are one-to-one, meaning they pass both the horizontal and the vertical line test, because then they're invertible. Right? If something passes the horizontal line test, then when you invert it, its inverse will pass the vertical line test and be a function. Okay, so what? Why am I talking about all this all of a sudden? Well, we're talking about sine inverse, cosine inverse. Right? Inverse functions. And I just said, what did I just say? Something's only invertible if it's one-to-one, meaning it passes both the vertical and horizontal line test. So sine, what's sine graph look like? We just did sine graphs, right? Up and down and up and down. And cosine's pretty much the same thing. Does the sine pass the vertical line test? Well, yeah, absolutely. Absolutely, right? Every vertical line only hits one dot. Every vertical line only hits one spot. Great. How does it pass the horizontal line test? No, it infinitely fails the horizontal line test, right? Here's a horizontal line, but it's not so horizontal. But it hits infinite points. It miserably fails the horizontal line test. So does cosine. Well, then how are we talking about the inverse sine? I just said, if you fail the horizontal line test, then your inverse is going to fail the vertical, and you don't have an inverse. Yet, we're doing sine inverse. We just did one. And yet you and I are looking at the sine graph and saying, but he fails the horizontal line test. Right. Thus, the restrictions. Because of that, they say, yeah, we can't really invert the whole sine, because he would fail the horizontal line test. So let's just take a part of the sine. That's what they did. So let's just take a part of the sine. So what part? Any part that won't fail the horizontal line test. So they said, let's just take it from the bottom here to the top there. Just that. Because if he starts to come down, oh, no, he's going to fail the horizontal. So don't have that part. And if he starts to come back up, oh, no, he's going to fail the horizontal. So he said from the bottom to the top. That's from negative 90 to positive 90. They say, we'll just take that little piece of the sine and invert just that. That's what the inverse sine is. It's not an inverse of the entire sine. It's an inverse of only that part, the restricted sine. That's what the restrictions are. They had to do the same thing with the cosine, the tangent, and on you go. So there it is. That's the theory behind it. So what? So enough with the theory. That was pretty quick. That's pretty good self-control for me, keeping that theory that small. All right, so now, what does that mean? So here's the actual brass tacks. Here's what you actually need then. So I like it on the unit circle. Sine inverse and tangent inverse are both restricted from negative 90 to positive 90. And cosine inverse is from 0 to 180. It is helpful to memorize those or put those on your, that's something you should put on your final exam sheet. I would put that on my final exam sheet. Really, I'd try to put that in my long-term memory if you could, because it comes in handy every now and then when you're dealing with inverse trig functions, because it explains why the calculator will do certain things that surprise you at times. Anyway, many times I've taught calculus and we'll be doing some inverse trig thing, and students will be like, "What, Mr. Aaron, why is my calculator telling me this weird angle with the inverse da-da-da?" And I always go, the restrictions, remember the restrictions. It's always a restriction. So anyway, so there it is. All right, so now, what does that have to do with this question?
Those restrictions just show the degrees, but the restrictions also from -1 to +1, right?
Oh, as far as the y values. Yeah, right. So that's just domain and range and that kind of thing, right? Yeah, we'll get to that. Yeah, you're totally right. Should I do that on this one? Yeah, let's just go forward on this one. All right. So now, as you look at this question, tangent inverse of tangent of negative 2 pi over 19. There's something that you're supposed to think right away that they're wanting you to think. Let me help you think that if you're not. What if I said, "Hey guys, I've got my toaster." Okay, let's go back to the toaster thing. Let's make it real. Got my toaster. Okay, and then I've got my inverse toaster. I'm going to take a piece of bread, and I'm going to put it in my toaster. In fact, I'm not writing this very well. I'm going to put my piece of bread. Here's my toaster. All right, there's what I want to do. I'm going to take, and this is inverse. Okay, I'm going to take my piece of bread and I'm going to put it in my toaster. Right, we're always plugging functions from right to left, right? You go f of 3, and that means 3 goes into f, right? It's always right to left. That's the notation of functions, right? So I'm not doing anything different than you're used to. So I'm taking a piece of bread and I'm plugging it into my toaster. Put it in, push down the lever, wait a few minutes, up pops. What comes popping out of the toaster? Well, toast. And then I'm going to put it into my de-toaster. Bought it from Walmart last Christmas. My de-toaster. Going to put that toast into my de-toaster. What's going to push down the lever, I guess? A few minutes later, what comes out? De-toasted. De-toasted. It's back to bread. It's back the way it started, right? If you take anything, you put it into the toaster, then put it into the de-toaster, it's back the way it started. And that's going to be true anytime you take anything, put it in a function and his inverse, it should be back the way it started. Because the inverse function should undo the regular function, shouldn't it? Does that make sense? That's what it does. They undo each other. They're opposites. Right? So as we look at this question, take any angle, put it in tangent. Tangent does its thing to it. And then you put it in inverse tangent. And that undoes whatever tangent did to it. And it comes out to be the way it started. Make sense? It just undoes it. Most of the time. The exception is the restrictions. If it wasn't for the special sine cosine restrictions I just told you about, that would just always automatically be it. Every time. You just go, well, it's always it. What do you mean? It's always. It is except for when they go outside the restrictions. If they give you an angle that's outside of the restriction zones, then the trig function will throw it back in the restriction zone. And thus the answer will come out different but it's the same angle in the restricted zone. So for example, if they gave me 370 degrees, that's more than a whole circle. That's really 10 degrees, right? Right, so if I ran it through the two things, it would give me back the 10-degree answer. It wouldn't give me 370. Is that making sense? It throws it back within the restricted zone. So that's the only thing you got to watch out for. Otherwise, yeah, they undo each other. It comes back the way it started, other than the restricted zones. You got to watch out for that. All right. Now, the question is negative 2 pi over 19 in the restricted zone? Well, what's tangent zone? Negative 90 to positive 90. So we have a calculator. Plug in minus 2 times 180. Remember, pi is 180, right? Over 19. I think it's between negative 90 and positive 90. What is it? Negative, what? 0.33069. So yeah, it's totally between negative 90 and positive 90. So it'll just come back the way it started. It won't throw it anywhere. It's already in the restricted zone. Does that make sense? So if the angle is in the restricted zone, it just comes back the way it started because it ran through a function and is inverse. Good? All right. Okay, tangent inverse to tangent. So we'd like to say the answer is 9 pi over 10. We'd like to say. If 9 pi over 10 is within, I'm supposed to say within the restricted zone. And what's the restricted zone for tangent inverse? Negative 90 to positive 90. So the question is that in the zone? So 9 times 180, change to degrees, right? That is 1897. 162? 162, uh-oh. No. He's outside the zone. Right? The 162, the 9 pi over 10, is outside the zone. So that will not be the answer. It's not going to be the answer, but the answer will be that same angle put back in the zone. Well, how do you know what that is? Yeah, same reference angle. It's the same reference angle. Yeah, boy, this is complex. I thought this was easier. I'm looking at the time thinking, I got time for this. All right, so you got to find the same angle in the what's it called? Reference angle. You got to find the same reference angle. So we must find the same reference angle in the negative 90 to positive 90 zone. It's on the screen, yeah. So we got to find the same reference angle in the zone. Now, what do I mean, the same reference angle in the zone? What's a reference angle? Remember that from Trig? It's the angle from the x-axis, not from the y. That's what a reference angle is. So what's our angle? It's 162. So 162 is almost to 180, right? There's 162. Almost to 180. That's my 9 pi over 10. Right, 162. So what is his angle to the, here's the x-axis. Reference is to the x-axis. Reference angles. A reference angle is to the x-axis. So what's the angle to the x-axis? Well, this will be pi minus 9 pi over 10. Why? Because this is pi to here. It's pi back up. It's pi take away 9 pi over 10. Is that making sense? Is it getting too complex? So this angle is pi minus 9/10 of a pi. So you take 1 whole pi, 10/10 of a pi. Right? That's 1 whole pi. Minus 9/10 of a pi. This angle must be 1/10 of a pi. Pi over 10. So that's the same angle over here. That's pi over 10 within the negative 90 to positive 90 degree zone. So the answer is pi over 10. That was complex, wasn't it? So did you follow that? So again, whenever you do two trig functions, inverse and regular, they basically cancel, except the answer will just be what you originally started with, as long as that angle is in the zone. If it's outside the zone, you've got to give it the same angle in the zone, meaning the reference angle. The reference angle. What's the reference angle? Same angle with the x-axis. Uh-oh, there's multiple hands. Have I done something wrong? Yeah.
Would it be negative pi?
It'd be whatever the same sign is. I think you're right. Let me make sure. What's the all students take calculus? So in the second quadrant, which is really where 9 pi over 10 is, sine is the only one positive, so tangent is negative. Sine and his reciprocal are positive. Tangent is negative. So it'd be where tangent is negative. Yeah, second quadrant. Thank you. It is that same angle in the second quadrant. Sorry, I was wrong. This is complex. So it's minus pi over 10. It's negative pi over 10. It's the same angle in the second quadrant. Yeah, so this is kind of complex. You got to think about this carefully. Does that make sense why that is? It's got to come out to be the same sign.
So when it's not in the zone, it would be whatever is left to make the fraction full for tangent. That's 9 over 10, 9 pi over 10. The answer is 1 pi over 10. So it's whatever needs to make the.
Yeah, it won't always be that way though.
Okay.
It's just for this one.
Okay.
Because it'd be different if it went further or was some other place. It wasn't in the second quadrant. Yeah. No, we can't make a more simple general rule. So it's in. Why is it? Do you guys understand that last step? Why is it in the fourth quadrant? Right. You understand the restrictions on tangent are fourth quadrant and first quadrant, right? Negative 90 to positive 90. So, yeah. Here's a way to make it simple. Basically, the restrictions for the trig inverse trig functions, they all do two quadrants, don't they? Right. Sine and tangent do the right two quadrants. Negative 90 to positive 90. Cosine inverse does the up two quadrants, right? 0 to 180. Okay, what does that mean? They both have first quadrant. All three of them have the first quadrant and one other quadrant, don't they? Do you notice that? Right? Cosine inverse is from here to here, right? They overlap in the first quadrant. So they all have the first quadrant, and then cosine has the second. Tangent and sine inverse have the fourth, right? Well, that means they all have one quadrant where the values are positive, because everything's positive in the first quadrant, and one other quadrant for negative values. So all you need to do is look at the angle they're giving you and ask them, hey, is tangent positive or negative? Then you'll know which of the two quadrants he's going to win. Whenever he kicks back out of where he's at, you'll know whether he goes into the first quadrant, the positive zone, or his negative quadrant, which is the fourth quadrant for tangent inverse. Right? 9 pi over 10 originally ends up in the second quadrant, right? Which is a negative zone for tangent. All students take calculus. Sine, only sine and his reciprocal are positive in the second, so tangent is negative there. So that's the thought you need to think. You need to go 9 pi over 10, second quadrant, tangent's coming out negative. So that's going to throw it back into the fourth quadrant. You know right away, fourth quadrant, which is in the restricted zone where tangent is negative. Not the first quadrant. That's a mistake I was making, right? And then the rest is the same. Just find the same reference angle. Reference means to the x-axis. So how far was 9 pi over 10 to the x-axis? Subtract those. Pi over 10, but it's in the fourth quadrant, negative pi over 10. Woo! All right. Let's type that in. Make sure. I don't got time for all this. These just take forever. They're not the most important thing in the world. I'm just going to give you the story kind of quick. This isn't the most important thing in the world. We got to get on. We got to start reviewing for the final. Tangent to tangent inverse of 9. This one's different than the last one. These are subtle. You might look and go, okay, 9. What is that? Is that in the zone? Is that not? Well, 9. Is 9 an angle, or is it an answer? And you can't tell. Don't think. Well, it doesn't have a pi or it doesn't have a degree. So none. They can fool you on all that. Don't rely on that. Look what it's being put into. What is that 9 being put into? Immediately into a tan inverse. What do you put into inverse functions? Angles or answers? Answers. 9's an answer. He's not an angle at all. So don't worry about the restrictions. He's good. 9, done. You don't even need to worry about the restrictions. Right? He's not an angle. He's not restricted. He's an answer. Because he's being put into tan inverse. Yeah, Mike, as you look back at the last one. The last one, they were plugging into the tan. The tan inverse was on the outside, right? Look here. Oh, you can't see anything. Look here. See? See, the 9 pi over 10 was being put into tangent. Thus, it was an angle on the last one. And the same thing on the one before, right? See how it was being put into tangent here, right? It was an angle. So then we think about the angle restrictions, negative 90 to positive 90. But on this one, they're putting the 9 into tan inverse. It's an answer, no restrictions. So they just undo each other, answer's 9. Don't even worry about all that stuff. Good? Does that make sense? You got to kind of pay attention to a lot of details. Always think that way with inverse trig. Is it an answer or is it an angle? Okay, tangent of tangent inverse of pi over 9. So ask yourself, is that pi over 9? Then don't think about pi or degrees or anything. That can fool you. Pi is just a number. It could be an angle, it could be a number. They can do all kinds of things with pi. Don't rely on that. Just say, who's it being put into? So it's an answer. It's not an angle, right? And so it's just pi over 9. It's not a restricted, it's not an angle at all. Everybody good on that? Because being put into tan inverse, it's an answer, not an angle. You put angles into regular trig functions. You put answers in the inverse trig functions, right? So it's an answer, no restriction, pi over 9, done. Good? On that stuff. Okay. Let's see. So I'm going to call it y. Y equals minus 3 cosine 7x. And they want me to find the inverse function. Okay. So how can I find, they want me to find, do you remember how to find inverse functions? So they want inverse function? Yeah, it's been a while. Let me review. To find an inverse, number 1, you switch x and y. I'm on the screen still. Yeah, switch x and y. Number 2, solve for y. Does that make sense? Switch x and y. So they just trade positions. Everything else stays put. So I switched x and y. Now solve for y. So how do I solve for y? Y is over here saying, get me alone. Here's the wall. I want to be alone. Get this negative 3 off me. Get this cosine off me. Get this 7 off me. I want to be alone. Solve for y. Y equals, right? Makes sense what we need to do. So what do I do first? Start on the outside like peeling an onion. Get rid of the negative 3 first. How do I get rid of the negative 3? Just divide. Boom. X over negative 3 is cosine 7. Well, good so far? We're peeling the onion. How do you get rid of the cosine? I want to get that cosine off of the 7y. Take the inverse of both sides. Right? Take cosine inverse of both sides. Cosine inverse this side. Cosine inverse this side. And cosine inverse cancels cosine. And you get cosine inverse of x over negative 3 is 7y. Does that make sense? Am I going too quick? Last step to get y alone? Divide by 7, or you can just put a 1/7, same thing. There it is. There's the inverse function. So it wanted me to find the inverse, which it did, and then find the range of f and the domain and range of f inverse. How do I do that? I don't know. I guess we're going to have to stop. We can never finish. There's always so much. There's a lot in this class. All right. We're going to stop. We got to do the domain and range next time. So we'll do the domain and range next time. I guess this won't be due till Wednesday. We got to finish more